Hello and welcome to today's episode of IT Galore. Today I want to tell you about my project MiSS. MiSS is an acronym for Maritime Interdiction Simulation System, and this is a software project that I'm working on, and it uses the Agile development process to aid in the construction of this particular software project. I have a presentation on Project MiSS, and so why don't we take a look at that right now. Hello, my name is Kevin Doyle, and this is my project, Project MiSS, and MiSS is an acronym for Maritime Interdiction Simulation System. Introduction. So what is MiSS? Well, MiSS is a control simulation. It uses Java Standard Edition now, and I hope to use Java Enterprise Edition in the future. It's an early stage open source project. Why would I want to build a system like MiSS? Well, I wanted to recreate a simulation between, or an encounter between a ship and a missile that occurred in 1982. This year, 2012, is the 30th anniversary of the Falklands War, and I also wanted to build experience across the entire software development lifecycle. So what does MiSS do? Well, it simulates an interdiction between the HMS Sheffield and an Exocet anti-ship missile, but there's a twist. HMS Sheffield is fitted with a close-in weapon system. So here we have the HMS Sheffield D80. It was a British Royal Navy. It is a British Royal Navy destroyer, and it was sunk off the coast of the Falkland Islands in 1982. Here we have an MBDA Exocet anti-ship missile, and the way these work, once they're launched, they dive to just above sea level, and they home in on their preset target. They're loaded with 165 kilograms of high explosives, so they cause quite a lot of devastation. And the final element then is the Thales Goalkeeper close-in weapon system. And this consists of a surveillance radar plus a tracking radar plus an autocannon, and these defend their their host platform, in this case a ship, by scanning for inbound missiles or shells or whatever. It tracks them, and once they're in a certain range, it unleashes a firestorm of I think it's 30mm cannon shells, and basically pulverizes the incoming hostile projectile. So now I want to present a system model view of the project, and it could be considered as a God's eye view of what's going on. So the first element that I'll just talk about is the synthetic environment, and this will obviously be created in software, and it composes of a number of models that help to provide real-world data. And those models include the GTOP 030, which is a geospatial and topographical model. The WGS 84 is the World Geodetic System, and that because the Earth is not a perfect sphere, it's kind of squished at both poles. This provides sort of kind of measurements and forces associated with that. You have the WMM 2005, which is the World Magnetic Model. The ISA is the International Standard Atmosphere Model, and the EGM 96 is the Earth Gravitational Model. And just as I have sort of illustrated here, that they're kind of all playing into this almost like a matrix type of a thing, where the different elements of the simulation will be affected by each of these models. The next element of the project is the generic vehicle platform. This platform is used to represent moving systems such as let's say the missile, in this case the Exocet missile, and also it'll be used to represent the HMS Sheffield. And so again, this is a standard way of representing system, I suppose any kind of a motion system or a platform, as they're kind of referred to, or combat. In this case, I'm referring to them as combat vehicles. The next element is the Thales Closein weapon system, and it's the Goalkeeper CIWS. And as I mentioned, it consists of a surveillance radar, and that provides potential targets for the multi-target track while scan, or TWS radar as it's known. Let's say the information provided here then is handed off to the autocannon, which unleashes the firestorm of 30mm cannon shells at any incoming unfriendly projectiles. The next element then is control. So the control system provides an interface between the synthetic environment and the generic vehicle platforms, and so that this is, I suppose, is another complicated system. I'll just show you the other elements plugging in to the control element now. So here we have the synthetic environment and all those 5 models plugging in here to different elements of the control model. The next element then is the generic platform, and again you can see that will is kind of central to the control and also to the synthetic environment. And the final element then is the CIWS, or the Goalkeeper Closein weapon system, which is in itself then controlled by the platform. So now I want to provide a software software development lifecycle view, and from an agile perspective of how this software project works. And as I mentioned, this is an open source project, so I keep the code on Google Code, and the URL for that is code.google.com/p/project-miss. And I also keep agile documentation and agile requirements, and the URL for that is sites.google.com/site/exoset goalkeeper. So here we have an agile workflow of how you would approach this project, how it is being approached. At the portfolio level, we have an investment theme here in the red box, and I just call it investment theme 1, and this particular theme it commands us to build a working low fidelity MiSS. So a working low fidelity sort of implementation of the project. And again, at a portfolio level, investment themes are broken down into epics, and epics are major releases of a particular software project. So I just take one of these to give an example. So the first epic that we're going to attempt will be here in the green box, and it's epic 1, and it instructs us to build a generic weapons platform, or a generic vehicle platform. And so that's the system that we saw previously. We have the generic vehicle or generic weapons platform, and it's basically to model thermal systems, power systems, actuators, mechanisms, aerodynamic structures, motion, and fuel systems and actuators. So at a program level then, these elements are broken down into what we call features, and we have feature 1 to 7, and I've picked feature 5. So features then are broken down into user stories at team level, and this is where the software developers will actually code and implement the functionality. So here I have feature 5, which instructs us to build the motion system. And I have that broken down into 2 user stories. So user story 1 instructs us to, as a motion system, I can trigger Newtonian equations so that MiSS, the Maritime Interdiction Simulation System, knows my relative position. And user story 2, as a motion system I can communicate with an IMU so that I can make course corrections. And you might notice here, if I am able to zoom in, in the agile approach to software projects, user stories are broken into a role, and in this case the role is a motion system, and they're broken into an activity, and in this case the activity is to trigger Newtonian equations, and they also consist of a sort of a business value section, and this is where business requirements are codified in code and realized in code. So the business value for this particular user story is that MiSS knows my relative position. So the system is starting to get, if we have this business value codified, then the software, it shows that the software is intelligent and is starting to model realistically what's happening. And obviously this is quite a good thing to have in our software, that it can add to, or it can lead to the software project becoming a viable software project that we could sell on the market. So let's now look at the next element. So here I just have an example of a factory pattern that I intend to use on the project, and it just has sort of generic abstract classes that will have I suppose a general description of what in this case what an anti-ship missile does, and also a sort of a general anti-ship missile factory, like how it should construct that particular piece of software. And then we have the more specific classes here that extend those abstract classes. Like we have an exoset factory, which is a very specific type of factory, and we have then a specific model of missile, which is the exoset MM40. So that will implement very specifics. It will actually implement the specifications of that particular model. So the exoset MM40 will implement the specification of an exoset MM40 missile. And so that's just some of the classes that I have there. It's probably difficult to see. And that's just a continuation then of the abstract classes that I have. And that concludes my presentation. When will I include this shit? Okay, no. Thanks for stopping by. War, or was it the? I can't pronounce the Spanish one. And also